Hi friends, in this video we solve gate problems related to Routh Hurwitz Criterion. The question is, the first two rows of Routh's tabulation of a third order equations are as follows. S cube is 2 2 and S squared is 4 4. Right? This is what they have given. This means they are giving 4 different roots and simply they are asking what is the value of two roots and where it is located. Let us see. So from this we can identify, from the table I can identify the characteristic equation. It is starting with S cube. So S cube coefficient is 2. So 2 S cube. Then S squared coefficient is 4. Then S power 1 coefficient is 2. S coefficient, S power 0 coefficient is 4. So that is equal to 0. Okay, it has what you call cubic polynomial. So we can find what is the nature of the system or root location from the direct shortcut. So what is the thing? First you find the product of inner terms. So it is 4 into 2, 8. Here also outer product coefficient, product of outer coefficient, that is also 8. So 8 is equal to 8. Inner product of inner coefficient is equal to product of outer coefficient. The system must be marginally stable. Marginally stable means there must be two roots in the complex plane, imaginary axis. So there must be some poles here like this, right? Then only we can say the system is marginally stable. So how can we find roots? Roots means the roots, poles or roots means roots of the characteristic equation. I find the roots of the characteristic equation. From here you see S squared factor is 4 and 4. So it is 4s squared plus 4, that is equal to 0. This implies S squared is equal to minus 1, S is equal to plus or minus j. This indicates two roots are in complex plane, imaginary axis. One is plus j, another one is minus j. So you see the system is marginally stable means there is no pole at the right hand side. There must be some other third pole should be in the left hand side. Because it is a third order equation, we should have 3 poles, 2 poles on the imaginary axis, 1 pole should be in the left side of the complex plane. So let us see whether it is right. 2 roots at plus or minus j, yes of course, but 1 root in the right half, no, 1 root in the left half. There is no root in plus or minus j2. Here also it is wrong answer. 2 roots at plus or minus j, 1 root in the left half of this plane. So this is satisfying this. Option D is the right answer. Next one, the number of roots of s cube plus 5s square plus 7s plus 3 is equal to 0 in the left half of the s plane is dash. So they are asking number of roots in the left half of s plane. Since as usual it is a third order equation, so directly we can find s cube plus 5s square plus 7s plus 3. So first what you have to find the product of inner coefficient. So 5 into 3, 35. Next to find the product of outer coefficient, 3. So 35 is greater than 3. Inner product is greater than outer product means the system is stable system. We know for stable system all the roots should be in the left hand side. So it is third order equation. So all the 3 roots must be in the left half of the S plane. Next one, a unity feedback system having an open loop gain of g of s h of s equal to k into 1 minus s divided by 1 plus s becomes stable when? So we have to use characteristic equation first. So what is characteristic equation? 1 plus g of s h of s is equal to 0. This is what characteristic equation. First we find, from that we will find when the system will be stable. So 1 plus k into 1 minus s divided by 1 plus s is equal to 0. This implies 1 plus s plus k minus ks is equal to 0. If I take s outside, it is 1 minus k plus 1 is equal to 0. For system to be stable, the coefficient of all the coefficients should be positive. So this must be positive. So 1 minus k must be positive. So this term must also be positive. Constant term must also be positive as per Routh Hurwitz criteria. So coefficient of all s factor should be positive. Constant term should also be positive. That means all the signs should be positive signs. So 1 minus k should be positive. This indicates k must be less than 1. K plus 1 is greater than 0 means k must be less than minus 1. Right? So, k must be greater than minus 1. K must be greater than minus 1. So, from these two, what we understand, k must be less than 1 and at the same time it must be greater than minus 1. This implies mod k must be less than 1. Right? So, that's what we are understanding from this. So, mod k must be less than 1. So, option C is the right answer. The next question is, consider a characteristic equation given by s power 4 3s cubed plus 5s squared plus 6s plus k plus 10. The condition for stability. So they have given characteristic equation. So we write Routh array. So Routh array can be written as s power 4. S power 4, it has coefficient is 1, even coefficient 5 and k plus 10. So this is even. It is s power 0. So k plus 10 is s power 0. S power 4 even number is 1. This is 1. This is 5. This is even coefficient. Next we write odd coefficient 3 and 6. 3, 6. Now what we have to do? I have to find s square. S square means this multiplied by this. So 1 into 6. Right, so 3 into 5, 15, 15 minus 6, 9. So 15 minus 6, 9 divided by 3. 9 by 3 is 3. So I can write it is 3. Next I multiply this with this, 3 into k plus 10 divided by 3, k plus 10. Right? Okay, s plus 1, s power 1 coefficient is, how can we find 3 into 6, 18 minus 3 into k plus 10 divided by 3. Next, s power 0 coefficient. What is s power 0 coefficient? This is multiplied by this one multiplied by this divided by this factor. So what we get is k plus 10 only. Right? Okay. So from this what we are understanding, if the system to be stable, the first column should be positive. So this indicates k plus 10 should be greater than 0. This indicates k must be greater than minus 10. This is the first condition. Right? There should not be any change in sign if I want the system to be stable. So this column should, this number should be positive. Similarly, this one should be positive. So how can we find 18 into 3k plus 10 should be greater than 0. By 3, that 3 that comes here, it will become 0. So this indicates what will happen. So let me say it is 18 must be greater than 3k plus 30. So 3k must be less than minus 12. Right? So what is the thing? K must be less than minus 4. So my k should vary from k must be greater than minus 10. From here k must be greater than minus 10. From here k must be less than minus 4. So the answer should be greater than minus 10 to less than minus 4. Let us see, k must be greater than minus 10 to less than minus 4. Option D is the right answer. Okay. Next. Okay, what is the question? The characteristic polynomial of a system is given by q is equal to 2s power 5 plus s power 4 plus 4s cube plus 2s squared plus 2s plus 1. The system is stable or not, they are asking. So first we write a characteristic equation. Thus they are given. So we write Routh array s power 5, that is odd component we have to take 2. Next 4. What are the next odd component? 2. Then s power 4 even component, we write is different color. S power 4 coefficient is 1, s squared coefficient 2, 0 coefficient is 1. Next I find S cube coefficient. So S cube, why can I find this must be cross multiplied 4 minus 4 0. Then this must be cross multiplied by 1 into 2, 2 minus 2 0. So it is row of 0. Row of 0 means what we have to do? We have to take axillary equation. So axillary equation is this one. So this coefficient is S power 4. This coefficient is 2S square. This coefficient is S. That is equal to 0. Sorry, 1. Not S, it is 1. Okay. So how can I find the parameter? So we have to find, let us assume it is A means it is dA by ds is equal to 4s cube plus 8s plus 0. So the coefficient, new coefficient of s cube is 4. This one, second one is 8. Okay, now again we will continue the process. So s power 2 means what I have to do? Again I have to multiply this 2 and this 2. 1 into 8, 8 minus 8 is 0 again. Then this one 1 into 4, 4 divided by 4, 1. Right? So 4 divided by 4 is 1. Okay, what we will see, when we get first row, first element as 0, we have to add one small epsilon. Then you have to do the multiplication again. So 8e, right? And what is the thing? 8 epsilon, this is minus 4, right? Divided by 8 epsilon minus 4 divided by epsilon. Okay, right. So this is s power 1, right? S power 0 is 1 only, right? So s power 0 is 1. Let us see how to find whether the system is stable or unstable system. Okay, so let us see how can we find. This is 4 into 1. Okay, not we should not do this. Sorry, this is 1 into 8, 8 minus 8. This is 1 again 4, 1 into 4. This 4 should go here, right? So I'm really sorry. So it is 1 into 4 into 2, 8. 8 minus 8 is 0. So again next 1 into 4. It must be 4. Right? So 8 epsilon. Then now if you multiply, it is this one. So 8 epsilon minus 16. Please change it. 8 epsilon minus 16. Right? So you see, when you remove this epsilon is equal to 0 after the completion, what will happen? It is 8 minus 16 by 8 epsilon minus 16 divided by epsilon, right? Okay, so this will be equal to 4. So it comes like this. So what we have to do, we check our axillary equation, because if we make epsilon 0, again it will be a problem. So let us see what is happening to our axillary equation. From here we will understand dA by ds is equal to 4s cube plus 8s. So if row of 0 occurs means, what is the meaning? Row of 0 indicates there is a pole in, there is a symmetric pole, right? There is a symmetric pole. Fine. So how many symmetric poles are there? That we can find from this axillary equation. So what is the axillary equation? 4s power 4 and it is 4s, sorry, it is s power 4 only, not 4s power 4, it is s, right? So it is s power 4 plus 2s square, s power 4 plus 2s squared plus 1 is equal to 0. Right? If I simplify, what I get, how can I simplify this? This I can write as s squared whole squared, s squared plus 1 is equal to 0. It is s squared plus 1 whole squared is equal to 0. Right? A squared plus 2ab plus b squared. This indicates s squared plus 1 into s square plus 1 is equal to 0. So I get s is equal to plus or minus j and s is equal to plus or minus j. That means what? I have repeated pole in imaginary axis. 2 plus j, I have 2 poles. Minus j, I have 2 poles. Repeated pole in imaginary axis indicates it is unstable system. Right? So the system is unstable. So no need to bother about this. Directly you can write the system is unstable system. Next question is the open loop transfer function of a unity feedback system is given by this equation. What is the range of k for which the system is stable? So as usual we have to find the first characteristic equation. From that Routh array we find. From Routh array we can find the answer. So what is characteristic equation? 1 plus g of s h of s. H of s is equal to 1. So 1 plus k divided by s into s squared plus s plus 2 into s plus 3 is equal to 0. Right? If you simplify, what we get is s power 4 plus 4s cubed plus 5s square plus 6s plus k is equal to 0. Okay. So I write Routh array now. S power 4 means even coefficient I write. S power 4 coefficient is 1, s squared coefficient is 5, constant term is k. Right? Similarly, s cube coefficient is 4, next to odd power is s, that is 6. Then s square I write 4 into 5, 20, 20 minus 6, 14, 14 by 4, 7 by 2. This is 4k divided by k, 4 it is k. Next s power 1, this one I can write 6 into 7 by 2, 6 into 7, 42, 42 by 2 is 21 minus 4k divided by 72. Fine. So next s power 0, if I multiply this, it is this factor will come as it is. We know it is a short way. So s power 0 is k. This indicates for stable system, the first column should be positive. So this indicates k must be greater than 0. This indicates 21 minus 4k must be greater than 0. This indicates 21 must be greater than 4k. So k must be less than 21 by 4. So k must be greater than 0 and k must be less than 21 by 4. So k must be greater than 0 and k must be less than 21 by 4 for system to be stable. So 0 to 21 by 4. So option A is the right answer. K must be greater than 0, less than 21 by 4. Right? So I hope you understand all the 6 problems. If you have any doubt, please ask me in comment section. I will clarify. Thank you.